Okay guys, so quicker version of the video that didn't work, and hopefully the sound comes through on this one. So this is what I gave you last week to have a look at, and I suppose in the first video I kind of went through bits and pieces. So I just, and what I've done here is what you do. So going from a decimal to a percentage, you're looking for the what the ninth value is. So this is going to be 900s, this is going to be 9,000s, and so on. And I went through here how you change from a fraction to a decimal, and I did out some of the solutions to the questions. But what I want you to do is I want you to go back to the revision exercise you did last week, and I want you to use the solutions here to correct your homework in the homework file here on OneNote. Now I'm going to go back in to our new thing that we're starting, and we are down to the second lesson of the week. So I asked you to do these questions here for homework. So these were for today. So after you've corrected last week's revision exercise, you're onto the homework from today, and I've written in some of the answers, and all these are in the video. In the video on OneDrive. That anyone who managed to see it will have seen the video and hear me speaking through all of these. But this is just looking at patterns based on the notes that we went through last week. So if you have, for your first one here, square, square, circle, circle, square, square, the next one is going to be a circle, and that's the same for question 2 as well. You're going you're looking for the next one in the pattern, so the next 3 blocks. So if this is blue, 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 red, blue, that's a pattern. Then the next one obviously going to be blue, blue, red. So you're going to start from the start again. And pretty much all of these are the same until you get down as far as somewhere like here. So we can see here up in the start of question 4, you have triangle, square, circle, triangle, circle. And that's the first 5. And then the pattern keeps repeating itself. So it'll go 1, 2, 3, 4, 5 are going to be the 5 you see there. Then it's going to go back to the start to be 6, 7, 8, 9, 10, and keep going and going and going. And that's all well and good. You can work that out until you get to one of the big numbers. But if you are asked for the 200th tile, then you come against a problem. So in 5D, they ask us for the 21st tile. And that's going to be 5, 10, 15, 20, 21st. But you know that at the start of the sequence, the number 1 or the number 6 is always going to be a triangle. So our answer is a triangle for that one there. This the question 5 is the same idea. You're dealing with the different color marbles, and they're asked for the first 20 marbles of this pattern. So many times do you see a red marble in the first 20 in the first 20. So you're going to say, right, well, I have 6 marbles in the sequence. So in 20, I'm going to get 6, 6, 6, and 2. That's going to give me my full 20 marbles. Well, how many red marbles are going to be in that? Well, you're going to have 3 in the first 6. So in the first 6 is going to be 3 reds. In the second 6 is going to be 3 reds. In the third 6 there's going to be 3 reds. And the second 6, because we're only taking the first 2, there's only going to be 1 marble. So your answer to that one is going to be 10. Okay, and question number 6 is pretty much the same thing, in that you have the full sequence there. So your full sequence is all 6 in a row, and you're just repeating. So every 6 you're going to get red triangle, blue square, green circle, and so on. And I fill the answers in there for you and explained it in exactly the same way for the difficult part, which is part E. Okay. Going on then, you managed to see the video, you'll see me explain this in detail. But I suppose what we have over here is a sequence, a pattern. There's a pattern there. And you can have to read through the definitions yourself. If it has so everything in order will be a pattern, but if it has numbers, then we call it a number pattern. So or a number sequence. Okay, so here's our pattern: 6, 10, 14, and 18. And what I've looked at is what's the difference between 6 and 10? Well, it's going to be 4. The difference between 10 and 14 is 4, and the difference between 14 and 18 is 4. If the difference between them is the same, we say it is a linear pattern. So a straight line. Down here you can see what linear is. So linear means it runs in this straight line, a linear pattern. And because we have 4 here, and 4 here, and 4 here, we call this a common difference. As in the same difference. Okay, so another one down here, you have 6 and 10 and 13 and 15. And say, well, the difference between 6 and 10 is 4. The difference between 10 and 13 is 3. And the difference between 13 and 15 is 2. So there's no common difference. So there's no common difference, it's not going to be linear. So you won't get a straight line. That's our first one. If the common difference is the same, it's going to be linear. Down after that then, I did a couple more here in the video that I shared with you on OneDrive, that the difference between, over here at A, difference between 11 and 18 is 7. And 7 here is the difference, and 7 here is the difference. So this is going to be a linear one. Same here, the difference is -3, -3, and -3. That's also going to be a linear one. But over here, the one we did a second ago, there was no common difference, so it's not linear. So that's the first thing. If it has a common difference, you're going to be linear. You might see these things here. What's T1 and T2 and T3 and T4? That just means term 1, term 2, term 3, and term 4. If I go up here to our own example, I could call this T1, T2, T3, and T4. We get to the T's later on when we're looking at things like Tn. Don't worry about that for the moment. Going down a bit further then, they do a couple of examples out for us. So this example here is just they write out the different terms for us. So term 1, term 2, term 3, term 4, term 5, term 6. And they write out all the numbers in the pattern or the sequence, so number sequence. And they write out the differences. The differences between all of them is going to be 7. So this one here we could say is going to be linear. So this is going to, so we'll call this one, this is linear. And this one here is going to be linear. They could also ask us to keep going and finish them. Well, if the difference is always +7, we could write out, and I could probably get you to say, right, give me T8 or T9. And you're just going to keep adding 7 to that to get T8 and add 7 to that to get T9. Same down here, we could do T8 and T9 down here in B. Okay. The other thing, one more thing they can do is they can ask you to go from number sequences into words. So you might have to say, right, our sequence is 7, 10, 13, and 16. So if we go out here and have a quick look at that. So 7, 10, 13, and 16. And we look at the difference between the three. The difference in there is 3, 3, and 3. So they're all +3, +3, +3. So I could say, okay, well, we know that it is a linear sequence, a linear pattern, a linear sequence, and the difference is 3. So they could give us some of this and ask us to draw this, ask us to come up with what the pattern looks like. Or they could give us the pattern and ask us to put it into words. Either one they can ask us to do. Then we get into, what if the common difference is not the same? So what if we have one over here that I did the other day, that 18 to 20, 18 to 20, 20 to 20, and 20 to 18. So the difference between 18 and 20 is 2 plus 2. The difference between 20 and 20 is nothing. And go from 20 to 18, you have to take away 2. Straight away there, before you go down any further, we can say that this is not linear. So because the common difference is not the same, it's not linear. But we can go down a bit further. And we can say, well, can we have a look at the second difference? So we say this is the first difference. And this is the second. Well, the second difference, the difference between, to go from 2 to 0, you take away 2. To go from 0 to -2, you take away another 2. So the second difference is the same. Okay, well, what does that mean? Well, if the second difference is the same, instead of it being a linear function, we call it a quadratic, not function. Quadratic sequence or a quadratic pattern. And quadratic patterns don't look like the straight line. They look like this curvy shape like this. So they can look like a curvy shape up, an N shape, or they can look like a U shape. So if the first difference is the same, it's going to be linear. If the second difference is the same, it's going to be quadratic. And the third one we wanted to have a look at is this third is if the second difference is not the same. So we can say if this is the same, we're going to be linear. If this is the same, it's going to be quadratic. But if neither of them are the same, so we say, this example I did here, we have 2, 6, 18, and 54. So I'm thinking, I'm going to go first here and see, is it linear? Well, we've plus 4, plus 12, and plus 36. So it's definitely not going to be linear because the first difference is not the same. We go again. The difference between 4 and 12 is 8. The difference between 12 and 36 is 24. So the second difference is not the same. So it's not going to be quadratic. And the last one we need to look at in patterns for the moment, if the second difference is not the same or the first difference is not the same, then it's going to be exponential. And exponential, you might have heard of in COVID, an exponential difference is like this here, this curvy shape. So COVID had exponential growth, means it's going up and up and up and up and up. And they do a couple of examples like that there for you out as well. We call it an exponential pattern where everything's doubling. Okay. So what I'm going to do is I'm going to leave you to have a look through those, but that's this essential message. When you get a pattern, it's all in this example here. When you get a pattern, have a look at the numbers. Look at the difference between the numbers. So what's the difference in 2 and 6? If the first difference is the same, it means it's linear. If it's not, well, we go on and look at the second difference. If the second difference is the same, it means it's quadratic. Then we go on again and we look at the if the second difference is not the same, it's going to be exponential. And you have examples of all three of those there. So what I'd like you to do is have a go with some of those. So then the homework here. Here's the homework to be uploaded to the homework section by Monday. So it's not due till Monday. There's a couple of questions there. I've highlighted them for you. Down here I did one of them out for you. So I took which one did I take? 8B is done out for you. So I was wondering, is it what type of pattern it is? And so I looked at the differences between all of these here, and the difference was different. So I found out it wasn't linear. I went again to the second difference, and the second difference was the same. So I could say then it's a quadratic pattern. So if I was to have to draw that, it was going to be either an N shape or a U shape. Okay, so give them a shot. Ask, send me an email or ask if you need to, but not to be done for Monday, but upload them to your homework section of your OneDrive by Monday. And I'm sorry again about the videos and the conference and all that. I'm not sure what's going on with the old computers this morning. It could be a Wi-Fi thing. I'm not sure, but sure, we'll see how it goes. Talk to you there.